Number 12A, homework 12A, number 2. Remember that your homework in your own Stats Personal account, when you pull it up, the numbers that are pulled up most of the time are different generated numbers. So, I mean, look at these videos, but understand that these numbers that are shown in these video tutorials aren't always exactly the same. So the reason that we do these video tutorials are obviously to show you the process so you'll be able to know how to do it on your own. So if what you're doing is looking at these video tutorials to just do your homework for you, it's obviously the wrong approach. That's obviously that fails the whole reason we do these videos. Um, and it makes me really not want to do these because I feel like they might be too much of a crutch for you, and they don't allow you to struggle and go through the process. So if you're doing these videos just to let it do the homework for you and not necessarily using it as a tool, then you're hurting yourself. But anyway, I just want to make sure um, that all of you watching these videos understand the purposes of these videos. Make sure you go and struggle for a while and figure it out on your own. And then when you want to see if you got the right answer or not, then refer to these videos. But make sure you put in the time yourself, not just have these videos as a crutch. Anyway, I'll solve number 2. It says an instant lottery game gives you probability 0.04 of winning on any one play. Plays are independent of each other. If you play 3 times, the probability that you win on one or more plays is about. First, let's identify that the probability of win, as it says in the question, is equal to 0.04. So that means that the probability of losing, if we wanted to, just write that out, probability of losing is 1 minus 0.04. And you know this because in the lecture, if you remember, one of the rules of probabilities are the probability of the complete sample space must be equal to 1. So the complete sample space, just playing the game altogether, you can either win or lose. So win and lose, the entire sample space is 1. And so if you subtract the probability that you have of winning, then you get, the probability of losing. And what is that? That's obviously 0.96, right? So in the question, we are asked, if you play 3 times, the probability that you win on 1 or more plays is about. So let's think about that. If the entire sample space of playing 3 games is 1, to solve for the probability of winning 1 or more, all we need to do is subtract the probability of losing 3 times. And there's, in the entire sample space of playing 3 games, there's only 1 time that you don't win 1 or more, and that's you losing all 3 times. So if we subtract the probability of losing all 3 games, then we get the probability of winning 1 or more. So the probability of losing all 3 is 0.96 to the 3rd power, right? That's the multiplication rule. That's 0.96 3 times. 0.96 times 0.96 times 0.96. So subtracting the probability of losing all 3 times gets us the probability of winning 1 or more. So 1 minus, and 0.96 to the 3rd power, if you put that in your calculator, it is actually 0.884. So 1 minus 0.884 is 1 minus 0.884, I'm putting it in my calculator, is 0.116. So going back to your options, your answer should be C, 0.12, right? So 0.116, you round that off to 2 decimal places, it's 0.12. So that's it. That's how you do number 2. Hope that makes sense.